If f and g are differentiable functions and the quotient f of x over g of x is also differentiable, then the derivative of the quotient f of x over g of x is equal to g of x times f prime of x minus f of x times g prime of x, all over g of x squared. Another way that this can be identified is taking the derivative with respect to x of a high function over a low function. The high function is the numerator, low function the denominator. So that'd be read as low d high minus high d low, all over low squared.
Low d high minus high d low, square the bottom and away we go. I'll use the quotient rule.
In our first example, we're going to find the derivative of h prime of x, where h of x is defined to be the function x squared plus 1 divided by x minus 4. So x squared plus 1 is the high function and x minus 4 is the low function. So to take low x minus 4 d high, which is 2x, minus high, which is x squared plus 1, d low, which is 1, all over the low function squared. Or gf prime minus fg prime over g squared.
Low d high minus high d low, square the bottom and away we go.
Simplifying the function by distributing the 2x and distributing the negative sign. No need to multiply out the denominator. And then combining like terms to get your final answer. For the next example, we're going to find d squared y over dx squared, which means it's to find the second derivative at x is equal to 2. And the function y equals 1 plus x cubed over x squared. So we have to get the first derivative, which is dy dx, low d high minus high d low over low squared. So x squared times 3x squared minus 1 plus x cubed times the 2x, all over x squared squared. Simplifying the problem to get 3x to the fourth minus 2x to the fourth, distributing the 2x and the negative sign. Combining like terms, get x to the fourth minus 2x over x to the fourth. Factoring an x out of the numerator, we're left with x cubed minus 2. The x in the numerator can reduce with one of the x's in the denominator, so we're left with x cubed minus 2 all over x cubed. That's our first derivative. Do the same process to get our second derivative, again a quotient rule. So we have low, which is x cubed, d high, which is 3x squared, minus the high function, x cubed minus 2, d low, 3x squared, all over the low function, x cubed squared. Make the problem a little bit easier, we'll just simplify a few by distributing. Distribute the 3x squared and the negative sign. And combining like terms to get 6x squared over x to the 6th, and reducing to get 6 over x to the 4th. Problem set to find the second derivative at x equals 2. So our second derivative was 6 over x to the 4th, and the second derivative at that value, x equals 2, notice the notation. Just replace in the value of x is equal to 2. Get 6 over 16, which reduces to make 3/8.